These are the video notes for transformations. In a transformation, something happens to a figure that causes it to move to a different part of the graph. One type of transformation is a translation. And in a translation, the figure shifts, and it can shift left and right or up and down. Looking at this first example, I'm going to start by focusing on point R. So point R is right here. And point R ends up at R prime, which is here. And I'm going to look between those 2 points to see how this shape shifted. It shifted this many units to the right, and then this many units down. So I can count the units now. So it went 1, 2, 3, 4, 5, 6 units to the right, and then 1, 2, 3 units down to get from R to R prime. So then the way that I can write this algebraic representation is each of the xy points of this figure, they shifted 6 to the right. So each of the x values, we added 6, and then 3 down. So each of the y values were decreased by 3. So y minus 3. Let's look at the next translation example. And you can pick any of the points, any of the original points for A, B, C. I'm going to look at point C, which is right here. And then I'm going to locate C prime, which is in the red triangle on the left, right there. And between C and C prime, it went to the left, and then it went up. So I'm going to count the units. It went left 1, 2, 3, 4, 5, 6 units to the left, and then 1, 2 units up. So 6 left, 2 up to get from C to C prime. So the algebraic representation, each of the xy points, we went to the left 6, so we subtracted 6 from each of the x values, and then we added 2 to each of the y values to bring them up, so y plus 2. So in general, if you are adding, that means you're going either to the right or you're going up. If you're subtracting, then you're going to the left or you're going down. Another type of transformation is a reflection. And you can reflect across either axis. In this first example, we are reflecting across the x-axis. So that's this axis here. Let's focus on one pair of points. And I'm going to look at point P, so right there. That reflects over the x-axis and ends up where P prime is. That's right here. The original point P, the coordinates of that point, that's an x of 2 and a y of 6. Then once it gets to P prime, when it flips over the x-axis, P prime, x value of that point is 2, and the y value of that point is negative 5. Sorry, and I'm just realizing right now that point P, the original one, that y value was positive 5. Sorry about that. And so in comparing these 2 points, I can see that the x value stays the same, but the y value changes sign between the reflection. So that means for my algebraic representation, I'll say for each xy point, when it's reflected, The x value stays the same, but the y value changes sign. So I'll say y would become negative y. Let's look at a reflection across the y-axis. So here's the y-axis. And let's focus on one pair of points. Let's look at Q and Q prime. The original coordinates of point Q are x of 6, y of 2. Then when Q is reflected across the y-axis, Q prime is x of negative 6, y of 2. Now let's analyze how that changed. Between those 2 points, the x value changed sign, but the y values between those 2 points stayed the same. So for my algebraic representation, for each xy point, when it's reflected across the y-axis, x will change sign, so x would become negative x, and y stays the same. The last type of rotation that you might see is a rotation. And whenever you rotate a certain number of degrees, in this case 90 degrees, and a certain direction, in this case clockwise. So that means what's happening is each point, like point A for example, is going to rotate around 90 degrees, a quarter circle, and end up right there. Let's look at the coordinates of those 2 points. The original point A was an x of 1 and a y of 4. The rotated point A is an x of 4 and a y of negative 1. Let's look at what happens. For my algebraic representation, each xy point, it was rotated, and then, let's see, so it looks like the x and y actually like rotated and traded places. So for my rule, I'm going to trade places. So y is now first and x is now second. And after it was rotated, the original x changed sign. So let's make that negative x. So xy becomes y comma negative x. Last one, a rotation 180 degrees. So in this case, if you start at point A is going to rotate all the way around a full half circle and end up right there at A prime. And with a 180 degrees, it doesn't matter if it's clockwise or if it's counterclockwise, because it ends up in the same place. The original point A, coordinates are x of 1, y of positive 4. The rotated point A prime, is x of negative 1, y of negative 4. Algebraic representation for each xy point. It looked like the x and the y stayed in the same place, but they both changed sign. So I'll say x became negative x and y becomes negative y.